It is now time to turn our attention to other measures of central tendency and measures of dispersion. So how much does the data tend to be the same and how much does it differ? The first one we're going to look at is we've already looked at using the average formula and we looked at using sum product. Let's look at the next one is a measure of the dispersion. Well, let's start with the median. Okay, the median is trying to find what the central number is. This is very important when you are looking at data that has outliers or numbers that are significantly larger or smaller than the rest of the numbers. This is like the guy that invests millions of dollars in his house at the end of the block. And so if you're calculating the average home value in your neighborhood, you would see that it is distorted because of this one house that's included in the average. And that outlier tends to upset the arithmetic mean, but it doesn't upset the median. Now, the way we would calculate the median by hand would be to come over here and take the two columns. Actually, you can just select the word age and go down here and say sort from smallest to largest. And so there we go. And we have 108. 108 divided by 2 is 54. So we would go down to the 54th number plus 1 for the header there. So it would be column 55. And there you could see that the number would be 11. Actually, since it's an even number, it would be the average of 54 and 55. So the average of 11 and 11 is 11. So we could say that the median would be 11. There's a way to calculate it a lot easier by just saying equals median and then selecting the data, shift control down arrow, enter, and it will tell you that the median is 11.0. The mode is the most popular observation. This is usually used for things that are categorical variables, not numerical variables. It's hard, for numerical variables we use the average. But for mode, for things like what color are your eyes? We want to find out what's the most popular color of eyes in the classroom. We get a bunch of people that are brown-eyed, a bunch that are green, a bunch that are blue, some purple, who knows. But the mode is the most popular or most frequently observed number. So we could say equals mode. And there's a couple of them here. There's a single mode, or if you have more than one mode in the room, we're going to use single mode. Oops. We're going to use single mode and select the same number, same range, and hit enter. And what do we get? The mode is 13. And if we go down here, we can see from our frequency chart that 13 was in fact the most frequently seen number. So that's the mode. All right, now let's turn our attention to measures of dispersion, how much the data is spread out. And the old battle axe here is standard deviation. And that has its own formula. And we can calculate the standard deviation by saying equal, STD. Now you'll notice up here there's a lot of different choices for STD. Standard dev.p, if you're taking the standard deviation of all of the data or the population. There's stdev.s if you're just dealing with a sample. That's the one we're going to be dealing with. So we select that one and hit tab and say, assuming that this were a sample, there's the data, and the standard deviation of that is 4.65. So we can say that's how much the data varies with respect to the age. So the average age was, 11.2? If we calculated the average, equals ABR average, Shift, Control, down arrow, enter. The average was 11.2 with a standard deviation of 4.7. So that's an indication of how much the data is spread out. Standard deviation is one of them. The other measure that we're going to look at is the interquartile range. That's if you're making a box plot. You want to know, we've already talked about the median, which is the middle of the data. And if you divide the data into 4 parts, they're called quartiles. The median is the second quartile, or the middle of the data. But the first and third are the 25% quartile and the 75% observation. So we can look at the quartiles, the range between the first and the third, or the IQR, and that will be equal to QUART. We're going to use quartile.inc, which includes the endpoints. So we're going to hit tab there. The array is from here, shift control down to there, of data. Now we're going to take the third quartile, so we put comma 3, close parenthesis, minus the first quartile. So QUARTINC, and the array is the same. We could actually type data, DATA, since that's the name of the data set, comma, the first quartile, close parenthesis, and we get the interquartile range. In other words, the difference between the third quartile and the first quartile is the interquartile range, and 50% of the observations are within that range, within the range of 6.0. So that's one way of figuring out how much deviation there is in our data set. Another one is the mean average deviation. This is called the MAD, the mean average deviation. It's much more used in when we get into regression, but I'll just show you quickly how to calculate it. It's AVDEV, AVEDEV, and if we click the data again, we see the average deviation from the mean is 3.76. Get rid of some precision here, and we're happy at 3.77. So those are different ways that we can calculate the deviation in a group. The last one that you're going to have to be familiar with is called the coefficient of variation. The coefficient of variation is simply the sample standard deviation divided by the sample mean. And we can actually go through that and say equals STDEV, STD, standard deviation dot S of this data, shift control down arrow, close parenthesis, divided by the average of the same data, shift control down arrow, close parenthesis, enter. So that's always a number between 0 and 1. No, it's not. But it is a number that is unitless. So we can say the coefficient of variation says that there is 41%, and we could put that in a percentage too. 41% variability. So those are our measures of central tendency and measures of dispersion.